Right, hello. Let's do some converting recurring decimals into fractions. So first things first, what is a recurring decimal? So 0.3 recurring, that's what the dot means, is 0.3333, and that goes on forever. Okay? Now turn that into a fraction requires a set of tricks, which I'm going to lead you through, and then we're going to do some harder ones. So the very first thing we do is we write down x equals 0.3 recurring. Now that's going to become really useful later on. Then we're going to times by 10, both sides. So 10x equals, when you times this one by 10, we move the dot down by 1, so it equals 3.3 recurring. Right, and if I write 3.3 recurring here, 3, 3, 3, 3, and that goes on forever, you can see that whenever there's a 3 here, there's also a 3 there, okay, after the dot. So if I was to do one of them, if I was to do this minus that, I get 3 minus 0, that's 3. 3 minus 3 is 0, 0, 0, 0, 0. So they'd all be 0 forever. And that is why we chose to times by 10. Because when we times by 10, this number is the same as that number. So we have 0.3 recurring here and a 0.3 recurring there. So our next step is to do 10x minus x, and that is 3.3 recurring minus 0.3 recurring. Now just as I've shown you a moment ago, that means this side equals 3, just 3, the recurrings are gone. 10x minus x is 9x. Right, divide by 9, x equals 3/9, and then we just need to simplify our fraction. X equals 1/3. There you go. And that's it. So, our method each time is we're going to times by 10, 100, 1,000, depending on how many steps we have to move the decimal place in order to get this to equal that. If it's just one of these, we only have to move it 1. We'll look at some harder ones in a moment. So let's just do another one like this to make sure that that's all pinned in. 0.5 recurring. Well, I'm going to say y equals at this time. This is just a variable. I'm just not using x so I don't confuse you. So 10y is 5.5 recurring. So 9y, 10y minus y equals 5. 5.5 recurring minus 0.5 recurring is 5. Divide by 9, y equals 5/9. And again, the reason why this became 5 is if I do 5.5555 going on forever minus 0.55555 going on forever, I could do 5 minus 5, 0, 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 5 minus 0, 5. And you see that these zeros are going to carry on forever. So you could think of it as 5.0 recurring, but that's just what 5 is. So, this side we get 9y, this side we get 5, we divide by the 9, and we get our fraction. 5s and 9s can't be simplified, therefore we have done as much as we can. So, let's now move on to the slightly harder ones. What do we do if we have 2 or more recurring decimals? So let's have a quick look at what that means. 0.47 recurring, and the dot above both of them means it's 0.474747. Well, now if we times this by 10, we'll get 4.74 recurring. These don't line up. So if we want them to line up, we're going to need 47.47 recurring, because that is 47.474747. Now you can see that these line up perfectly. So this time, when we do x, we say that x again, now this equals 0.47 recurring, so now we're going to have 100x, and that equals 47.47 recurring. The reason I've chosen 100 is I need to make the decimal place move twice in order to get these decimals again to line up. So what you can actually do is you go, how many are repeating? In this one we have 2 repeating, so we have to times by 100. If we have 3 repeating, 1,000. 4 repeating, 10,000. Okay, so now we've got them set up so that the decimals are lined up, so we can do 100x minus x. 100x minus x, that's the left hand side. On the right hand side we have 47.47 recurring minus 0.47 recurring, and these recurring bits are going to cancel each other. 100x minus x is 99x, and that equals 47. Divided by 99, x equals 47 over 99. Now, something I forgot to say earlier, the reason why this is showing that we've converted a recurring decimal into a fraction is we know that x equals, in this case, 0.47 recurring. But we've also just shown that x equals 47 over 99. Therefore, 0.47 recurring equals 47 over 99. Okay, let's do this with a slightly more complicated one. We've now got y equals 0.231 recurring. Now you could write it like that, but we don't. Right? We just write it 231 and put the recurring dots above the 2 and the 1. But it does mean it's 0.231 carrying on. This time 10x isn't going to help us. 100x isn't going to help us. Y isn't, sorry. 1000y is the first time that they're going to start lining up again. And that's going to equal 231.231 recurring. Okay? So that's 231.231.231.231. And again, when we do one minus the other, we're going to see that that cancels all the way along. Okay, so now we do 1000y minus y, which is 999y, and that equals 231.231 recurring minus 0.231 recurring, so that gives us 231. Okay, and then that simplifies by dividing by 999 to be 231 over 999. Now, that's not quite done yet, because we can see that 3's going to top and bottom. If you remember, add up the digits on top, 2 plus 3 is 5, plus 1 is 6, therefore 3's go into it. So we know we can divide top and bottom. Bottom will become 333, and the top is 77. Ooh. Okay, alright. That's not very nice. 11s. Do 11s go in both? No, 11s don't go in 333. So we're done there. Point is, at this point, you've always got to simplify. Okay, so 77, 7 times 11, 7s don't go into 333, 11s don't go to 333, right? Because that's just 3 times 111. So, we're done. Okay, so what you can see here is however many things you have got recurring is how many powers of 10 you're going to have to times it by. When at the beginning we only had one number recurring, you times by 10. When we had 2 numbers recurring, you had to times by 100. When we had 3 numbers recurring, you had to times by 1000. Okay, that is the trick to working out what you have to times by. Now there are a few other questions that work a little bit differently, and I'm going to take you through them now. They're basically the same, but you've just got to be careful. So, if part of it is not recurring, okay, this first one that we're looking at, 0.285 recurring, the dots are only above the 8 and the 5, so that is 0.28585. Note the 2 is not repeating. Okay, so we've got 2 recurring points on this. So then I write x equals 0.285 recurring, and we're going to times by 100 because there were 2 repeating, and that's going to equal 28.585 recurring. Now, you could have written 28.58 recurring. The reason I specifically write 585 recurring is so that we can see that these are going to line up. Okay, so over here, if I write it out again, we have 28.58 recurring. You could have written it like that. That would have been 28.5858585. They go on forever. Okay, and the point was, the reason we did this was because we wanted these to line up, and they do. They line up now. These don't, but that's not a problem, right? That's just going to, that is actually the entire problem with this situation, but we're going to solve that in a moment. So, just re-emphasizing, I wrote 585 recurring just because it makes it easier to see that the 8s line up and the 5s line up. Ooh, and that should have been 100x. So now we do 100x minus x on the left hand side, and that equals 28.585 recurring minus 0.285 recurring. Okay, 100x minus x is 99x, and on this side we have 28.585. Well, the 8 5s are going to cancel with the 8 5s all the way down, so we're going to have 28.5 minus 0.2, which gives us 28.3. Okay, well, that's not very nice. X equals 28.3 over 99. We never like having a decimal in a fraction, so we're going to get rid of that. We're going to times top and bottom by 10. As long as we do it to both, it's perfectly allowable. Okay, so now we're going to have 283 over 990. And there we go. Right, that's all you've got to do. So we saw there were 2 recurring numbers, so we times by 100, and then we brought them together. We did the 100x minus the x, which gave us our non-recurring value at the end. We divided by the number in front of x. We had a fraction. It wasn't how we leave fractions, so we now had to convert it to how we actually leave them. So in this case, we have to times by 10, but that's it. Right? Let's do it for the next one. 0.8017 recurring, right? Y equals, okay, I'm going to do 100y, because again I can see there are 2 recurring numbers. That is 80.1717 recurring. Again, I could have just written the 17 recurring here. The only reason I've written it there instead and explicitly put a 17 here is to make it absolutely clear that these line up. So when I do 100y minus y, I'm going to do this line minus this line. The 1s, 7s cancel. So we get 100y minus y, and that equals 80.1717 recurring minus 0.8017 recurring. Okay. Now I'm going to do this over here. It's a little bit harder. Right, the 17 recurrings will cancel, so I've got 80.17 minus 0.8. Okay, 7 minus nothing is 7. 11 minus 8 is 3, so it's 79.37. So 99y equals 79.37. So y equals 79.37 over 99. That's horrible. We've got a decimal place on top. We hate that. So we're going to times top and bottom by 100 this time to deal with it. 7937 over 9900. And there we go. Right? In concept, it's exactly the same. We look for how many decimal places we've got. We times by that many tens, 2 decimal places, sorry, not decimal places, how many recurring numbers we've got. We times by that many tens, right? So we have 2 here, so we times by 100. We still only have 2 here, even though it's all the way down there, so times by 100. Then we will do in this case 100x minus x, because that will cancel the recurrings out, and we are left with just some numbers. This one isn't actually a whole number, so when we divide it, we have to times by tens until we make top and bottom whole, and we have to look to see is there anything that we can cancel by. Okay. Now, dealing with numbers which are bigger than 1. Alright, so put down x equals 1.5 recurring. Got 1 recurring decimal there, so we're just going to times by 10. 10x equals 15.5 recurring. Then we do 10x minus x, which gives us 15.5 recurring minus 1.5 recurring. Our recurring numbers all line up, so when we take them away, that will disappear, and we will get 9x equals 14. So x equals 9 over 14. We don't like it to be, 14 over 9. We don't like it to be top heavy, and so we get x equals 1 and 5/9. Done. It's not really that much different from what we've done before. Now, let's do another one. Y equals 1.37 recurring. We have 2 recurring numbers, so we times by 100. 100y equals 137.37 recurring. So 100y minus y, 99y equals 137.37 recurring minus 1.37 recurring. So 99y equals 136. Y equals 136 over 99. Therefore, y equals 1 and 37 over 99. And there we go. I hope that's all made sense to you, and good luck with the rest of your work.